Hello friends, so let us begin our journey of preparation for mathematics portion related to JEE, and with the first chapter, which is basic mathematics. Now basic mathematics is a chapter which is like to bridge the gap between the students of across all the different boards, that is CBSE, ICSE and any other state board, and then when you come to standard 11th you start your preparation for JEE and your standard 12th with full speed. But there are a few things which are generally missed out on at times, and everyone is not very well aware of these basic concepts, which generally teachers and the school curriculum of standard 11th and 12th take it for granted, as in they expect you to already know this. So here is the first chapter of basic mathematics. Now in this chapter we are going to deal with some of the basic inequalities. Till now what we have done is we have studied questions which had equations and are equal to sign. Now in standard 11th and 12th, and more importantly in JEE, inequations become a very important part, because there can be many questions related to greater than something or less than something. Tell us whether this particular expression is greater than something or less than something. So this is what we are going to deal about in the section of basic inequalities. Then we are going to look at two important functions and their related questions. One of them is modulus function. Now this, I am sure you would understand when you are studying the chapter relations and functions, but in inequalities this is of very much of high importance, because there can be many questions related to modulus of a function. Then next is logarithms. As far as this topic is concerned, there are students who might have not studied this topic at a detail. So what we will try here and do is we will try and quickly revise all the different properties related to logarithms, so that you have a good understanding and you are at a position to take the course ahead. And towards the end we will study something related to sets, very basic things related to sets and Venn diagrams, which is quite useful in topics like probability and permutations also at times, and also for the sake of understanding of different situations when there are 2 or 3 events taking place. Sets and Venn diagrams is specifically useful. So let us begin our discussion with basic inequalities. So here let us look at some of the inequations which would be greatly used in this section or throughout your course. So the first thing is, if A is greater than B and B is greater than C, so if A, B, C are 3 numbers such that A is greater than B and B is greater than C, then according to this first inequality, clearly we can first write this implies A is greater than C. The second important inequality is, if A is greater than B and C is some number belonging to real numbers, then we have A plus C is greater than B plus C. So this is another important inequality. If there are 2 numbers such that one of them is greater than the other one, no matter what real number you take, if you add this number to both of them, the inequality sign remains the same as usual we might expect. Now the third is, if A is greater than B and there is a number C greater than 0, then A into C will be greater than B into C. Clearly, you would understand this equation as, let me explain here a bit. So if for example we say 3 is greater than 1, if we take any positive real number greater than 0, let us take 4, and if we multiply 4 on both sides, what happens is 3 into 4 always remains greater than 1 into 4. So that is some of the very basic inequalities that we need to discuss here. Now, what happens if C becomes negative? So this might be an obvious question that might come to your mind. Now here we have taken a number C which was positive, greater than 0. What if A is greater than B and there is another number C which is less than 0? Then what happens if we multiply this number C to both sides? So if we multiply A into C and we multiply B into C, what happens in this case is inequality changes. Inequality becomes reverse of what we had initially. For example, again, you can take 3 greater than 1, where A is 3 and B is 1. Now let us take the value of C instead of 4, minus 4, because we need a number which is less than 0. So what happens is 3 into minus 4 becomes minus 12, which is definitely less than 4 minus 4 into 1, which is minus 4. And hence we have this important inequality. If there is a negative number which is multiplied, what happens to the inequality is it reverses. So this is what you need to understand. We'll need all this while we're discussing the questions related to variables. Moving on to inequality number 5. So here let us say if A1 is greater than B1, A2 is greater than B2, A3 is greater than B3, and so on up till, let us say, AN is greater than Bn, where Ai and Bi are real numbers, where Ai, Bi belongs to the set of real numbers. So in this case we can write A1 plus A2 plus A3 and so on up till An will be greater than B1 plus B2 plus B3 and so on up till Bn. So this is one of the easiest intuitive inequalities that you can think of, and this would be used at many times. Now if this is the case, let me name this as 5a, because we can have another inequality if all these Ai's and Bi's are positive, greater than 0. So let me write here if Ai, Bi's are greater than 0, in this case we can have, so this is the second part of the inequality number 5, then we can also write product of all the Ai's, that is A1 into A2 into A3 into A4 and so on up till An is greater than B1 into B2 and so on up till Bn. So this is what we can have in case all these numbers Ai's and Bi's are greater than 0. Moving on to inequality number 6. Now suppose we have a number. If A is a number such that A is less than 1 and A is greater than 0. So that is to say, if A lies in between 0 and 1 and N is any positive rational number, then A to the power N remains less than 1 and greater than 0. And if we want to write A to the power minus N, it becomes greater than 1. So this is the inequality if A lies in between 0 and 1 and N is any positive rational number. Now what happens? An obvious question, if A is greater than 1. So if A is greater than 1 and N is again any rational number, then a to the power n clearly becomes greater than 1 and a to the power minus of n becomes less than 1 and greater than 0. So this is the case when a is greater than 1. Now also we could have written down one more inequality here. Now so this is related to 3. The next property here is property number 8, and this is if a is greater than b and b is greater than 0, then the reciprocal of a and b will be related in the following manner. That is to say, the reciprocal of a, 1 by a, will be less than the reciprocal of b, that is 1 upon b. Moving on to the 9th inequality. Now in this, if 0 is less than a and less than 1, and there are two numbers, m and n are positive rational numbers, then a to the power m. Now if m and n are two positive rational numbers such that m is less than n, then we can have a raised to m will be greater than a raised to n. So this is one of the important inequalities. If there are two numbers m and n which are positive such that m is less than n and a is a number between 0 and 1, if we raise a to the power m and a to the power n, the inequality reverses between m and n, and here you can see a to the power m becomes greater than a to the power n. Now what happens if, let us say, a is greater than 1? If a is greater than 1 and m comma n belongs to positive rational numbers, such that m is less than n again, then we can have a to the power m is less than a to the power n. So these are some of the very basic inequalities related to numbers. Now there are few more inequalities which I would like to discuss, and that is if a is a positive rational number, then a plus 1 upon a is always greater than equal to 2. Now this is a very basic and important inequality. I highlight this once again and ask you to please understand and remember this inequality, because this is something which you would require many times. Now you might ask, can we prove this? So you can prove this using AM greater than GM, which you will discuss in the section in the chapter progression and series or sequence and series. Now here, if you would like to prove, we can go ahead and do something like this. So let us say we have a expression a minus 1 whole square. Now if we have this expression where we are considering a to be a positive rational number, what we could say is this expression, no matter what value of a we take, is always going to be greater than or equal to 0. I mean, you agree, because any rational number squared is always going to be greater than or equal to 0. Now let us see what we have if we expand this. So if we expand this, we get a square plus 1 minus of 2a, and this is greater than or equal to 0. From here, if we add a number plus 2a on both sides, so if we add a number plus 2a on both sides, the inequality remains the same. So what do we have is a square plus 1 is greater than or equal to 2a. And now I want to divide this inequality by a positive real number a on both sides. Now if we divide, so dividing this expression or this inequality by a is equivalent to multiplying this inequality by 1 upon a. So if we do that, we have the following, and the inequality remains same. We have a plus 1 upon a is greater than equal to 2. So that is how we prove a plus 1 upon a is always going to be greater than equal to 2. Now you might also ask, what would be the case if a is a negative rational number? So here is the part B of this property. If a is negative rational number, then a plus 1 upon a is always less than equal to minus 2. Now using this above inequality, you can also prove the second one. Just try substituting a by minus 1 minus of b and you'll get the answer to this. So this is some of the basic inequalities. Let's discuss some more in the next session.